Welcome, ladies and gentlemen, to Lesson 8.2. I can solve simple two-step equations. Again, this is something that is leaping you into algebra and that you will need very much so in your 8th grade math class. So make sure you are paying attention and doing your best today and every day. Alright, so two-step equations. A two-step equation contains two operations. Hence the word two-step equation. There's two steps. So, in the equation, 3x plus 1 equals 7. What you think about is what's happening to x to get to the end result. So we ended at 7. X was multiplied by 3. Then 1 was added. And you ended at 7. So, how this works is to solve a two-step equation, you undo each operation in reverse order. Sometimes it's called reverse Pemdas. You will hear it's called inverse operations. Okay, so inverse means working backwards, inverse operations. And in Miss Simmer's classroom, there's a sign that says inverse operations for life. That is a club in 8th grade that you want to be a part of. So make sure you figure this out now. So, what we do, we are trying to isolate the variable, trying to get the variable by itself so that we can figure out what it was before something happened. So, we make two lines called train tracks or slide, and since x was multiplied by 3 and then 1 was added, since 1 was the last thing done, it's the first thing we undo. We undo adding with subtraction, so we're going to take 1 off. So we subtract 1 because 1 minus 1 is 0. And on this side, we're just left with 3x. Whatever you do to one side, though, you have to do to the other side. So 7 minus 1 is 6. Then x was multiplied by 3 to get to 6. So we undo multiplication with division. 3 divided by 3 is 1, so we have 1x. Whatever I do to one side, I have to do to the other. So 6 divided by 3 is 2. So I get x equals 2. A very important part of this is called a solution. This is a solution. This is what makes this first equation, what makes it true, what makes it remain equal. So you can check your solution by plugging it in and then doing forward order operations to make sure that it works. So to check your solution, you take 3, you plug in the value of x that you got where x goes. So maybe I can show that with another step. Maybe I'll go like this. Our original is 3x plus 1 is 7. So what number times 3 plus 1 will give me 7? Well, we found out that it was 2. So we replace x with 2. And we're trying to prove that these are equal. So then we do forward order of operations. 3 times 2 is 6, plus 1 equals 7. 6 plus 1 is 7. So since 7 does equal 7, this means that my solution is correct. If you were to end up with something like if I made a goof, say I got a 1, then I would get 4 equals 7, and that's not true, so that would tell me I was wrong. Alright, there's another one here. We're going to make train tracks. I'm going to rewrite it so I have a little bit better visual of it. So I always like to say, what happened to n to get to 25? So n was multiplied by 1/4, then subtracted 3 to get there. So you think forward order of operations, and then you will work backwards. So since subtracting 3 was the last thing I did, I'm going to undo that by adding 3, because negative 3 plus 3 is 0. So I'm left with 1/4 on this side, 1/4 n. Since I added on the right, I need to add on the left. And I get 28 is 1/4 of what number? So 1/4 of a number. How do I undo? So since I'm multiplying, I'm going to divide. But I remember that dividing fractions is actually the same as multiplying by the reciprocal or reciprocal, because that gets this to 1, and that's the goal. So I'm actually going to multiply this by 4 over 1. So I'm just left with n. So then I multiply this side also by 4. And if you don't have a calculator, here is a strategy. Do 4 times 20, which is 80. 4 times 8, which is 32. And add them together for 112. So we get n equals 112. But we better check our solution because that's the best way to know we did everything correctly. So we plug it in. So we say 25 is 1/4 of a number minus 3. So 25 is 1/4 of 112 minus 3. So 25 is multiply, then subtract. And since they're equal, my solution is correct. All right, so why don't you give these a try and then come back and see how you did. Start with your tracks. X was multiplied by 3, then added 2 to get to 20. Last thing I did was add 2. First thing I undo is subtract 2. For 3, x equals 18. 3 times x equals 18. Undo multiplying by dividing. 3 divided by 3 is 1. We get a 1x. 18 divided by 3 is 6. Check it. Does it work? 3 times 6 plus 2 equals 20. 18 plus 2 should be 20. 20 does equal 20, so my solution is correct. Just because the variable is not first, doesn't matter. I'm multiplying n by 2, then adding 5 to get to -1. Take away 5 on both sides. Left with 2n is, add the opposite, that's a -6. Undo multiplying by dividing to get 1n. Same thing on both sides. Negative divided by positive is a negative. Then, of course, plug it back in to check. For your video's sake, I'm going to keep on going. Train tracks. A is being multiplied by 1/2, then adding 9 to get to -1. Undo adding with subtraction on both sides. Gets to 0. Left with 1/2 A. Add the opposite. Get a -10. Dividing fractions is easy as pie. Flip the second and multiply. So you multiply by the reciprocal. 2 over 2 is 1. Left with 1A. Multiply by -2 on this side. We get a positive 20. So A is positive 20. Is that right? That seems incorrect. Did I do something wrong? I did. So see what I would have done had I plugged that in. If I plug in -20, let's see what happens. So if I plug this in, -1 equals 1/2 times 20 plus 9. So I get -1 equals 10 plus 9. -1 does not equal 19, so I know I did something wrong. I go and check. I multiplied by a +2 here and a -2 here accidentally. So my answer should really be a -20. And that, my friends, will make all the difference. The negatives do matter. So sometimes there's negatives. Pay close attention here. This is the biggest issue for 8th graders. So common mistake is that you think that because you see a subtraction sign that you should add 6. But we are not subtracting 6. That's not reversible. So what we're going to do is rewrite this. And we are going to add the opposite so that we can see that that is actually a -3x. So then we see we're adding 6 and we need to subtract 6. 6 minus 6 on both sides. Bring down the -3x. So sometimes people just bring down 3. We want to see that that's a -3. Equals 15. Undo multiplication with division. A positive divided by negative is a negative. Don't forget to check. So we replace, we multiply, we chop to see that we're adding, and we see that it's true. Pay attention to that one. All right, a couple more with the negatives. Pause and come back and just check the answers if you want to. If you get them wrong, then see the work. So I'm going to see that to get rid of 10, 10 minus 10 will get me to 0. If you add 10, you'd get 20. We don't want that. So then bring this whole thing down. Negative 2/3 p is 42. Multiplied by the reciprocal 3/2. They cross cancel. Same thing on the other side. Multiply, you put numbers over 1. Negative times a positive is a negative. 2 goes into 2 once. 2 goes into 42 21 times. 21 times negative 3 is a negative 63. Plug it in and check. X is multiplied by negative 3, added 2. Last thing I did was add 2. First thing I undo is subtract 2. Gets to 0. Left with negative 3x. Add the opposite, negative 21. Undo multiplication with division. Negative divided by negative is a positive. X equals 7. This makes this true. This one's a little tricky. Pay close attention. So, if you think forward order of operations, n was first divided by negative 3, then subtract 2. So I need to add 2. N divided by negative 3 equals negative 16. Multiply. So this is really like there's a 1 there. So we undo dividing by multiplying by negative 3 because they cancel. A negative divided by a negative is a positive. 16 times 3 is 48. All right, sometimes we're going to have to apply yesterday's things, combining like terms. And so you have to combine like terms first. So you just simply, if you want to add the opposite, do that. Sometimes you just have to add like terms first. So we do negative 2 plus 1 is a negative 1y. Minus 5 equals 11. Add 5 to both sides. Better keep my train tracks to stay organized. And I get a negative y equals 16. Can't have a negative 1 here. So to get rid of this negative 1, I multiply or divide by a negative 1. Because the negative divided by a negative is a positive. Positive divided by a negative is a negative. And then they plug it back in to both spots to check that they remain equal. Try here, and then we'll be on our way. 1 plus 4, 5x equals 45. Undo multiplication with division. X equals 9. Plug it back into check. So 9 plus 4 times 9 equals 45. 9 plus 36 is 45. 45 is 45. My solution works. Combine like terms. Not everything, just the ones that are alike. 10 equals 2 plus a negative 1 is just 1a. Take 13 away. A is equal to a negative 3. Ooh, this one's a little bit different. We have a fraction. Fraction with the number. So we're adding, this is the same as 2.5. So we're adding 2.5 to negative 5. fractions, you need common denominator. So it's really negative 5, which is the same as negative 10 over 2, plus 5 over 2, which would leave us with negative 5 over 2. So we really have negative 3 equals 6 minus 5 over 2w. Subtract 6, because 6 minus 6 is 0. Add the opposite. So negative 9 is negative 5 halves w. Multiply by the reciprocal. 2 cross cancel. Multiply by the reciprocal over here, putting 9 over 1. And you get 18 over 5, which simplifies to a 5 goes into 18 3 times, with 3 of the 5 remaining. You can plug that back in to check. All right, so a lot of different things that you saw. The biggest things are that you remember inverse operations, doing reverse PEMDAS, and you are trying to find out what the variable was before the operations happened. Okay? We'll stick with the basic ones if we need to, and you'll get to challenge if you need to. Write down questions. Goodbye.